I want to thank Jerry Pollack and all the whole organization of this beautiful interdisciplinary conference. And I will speak about fluorescence behavior of a supramolecular H2O architectures generated by perturbing pure water. You will see, this seems something very particular, but you will see how general it is, what is happening. I want to present briefly myself. I founded almost 20 years ago, in 1997, this spin-off company of the Italian Research National Council. And this company, it is a micro company, and it is performing technology transfer in these three areas in particular. And somebody of you already knows who is this person. Everybody knows. And what is this object that Leonardo was drawing many centuries ago? It is something that was forgotten totally until the beginning of last century, for 400 years. And it was discovered again, and then these drawings of Leonardo, after the ball bearing was reinvented, it was discovered, the manuscript of Leonardo, in which he was doing this. So technology transfer, it is very important to avoid that something like this happens again. This is the idea. Okay, so let's speak about water. I will speak about a work that is obviously a cooperation work starting from the Vittorio Elia 20 years research. And these are the authors of a paper that almost is being published in Water Journal. So, this is important to introduce the context. In effect, what is happening is the following. Micron-sized supramolecular H2O aggregates are producible by perturbing pure water. What does mean perturbing? This means immersing a hydrophilic membrane in molecule water, in particular naphthalene, but not only, stirring the liquid, removing and drying the membrane, and then repeating these steps. In particular, this is iteratively naphthanated water using naphthalene. Iteratively naphthanated water shows a fluorescence spectra consisting of a broad band spanning from 290 to 550 nanometers. It is important that to ensure that impurities, that is, molecules released by the membrane, organic or possible biocontaminants, do not underlie aforementioned phenomena. So we employed state-of-the-art analytic techniques. In particular, matrix-assisted laser desorption ionization time of flight, that is MALDI-TOF, and gas chromatography, both coupled to mass spectroscopy, and ion chromatography too. So, what is the result? The results are that the perturbed water only contains 10-6 molar fluorine and sulfate ions released by the membrane, and only minuscule amounts of contaminants. But what is happening? Strange. That lyophilizing the NEV perturbed water produce a ponderal solid residue. So let's understand what is happening in general, not only with naphthalene. Vittorio Elia group discovered in last years that if you have pure water, that is bedistilled water, and you are using physical perturbation on this pure water, large changes in physical chemical parameters are happening. In particular, pH, that is changing of also three points. Heat of mixing, electrical conductivity, that is changing also 3 orders of magnitude, that is from 1 to 1,000. Viscosity and so on. That is, there are happening very large changes in the liquid water properties. But the analysis are showing now very clear that it is still pure water. And the physical perturbations are many different physical perturbations with different objects, with different kind. So it is not possible that it is the same error, say, in this sense. But what we see that is, like Vittorio Lia yesterday was speaking, there is a circular dichoism. That means that are macromolecules. And also UV fluorescence, that is electronic energetic transition of this kind from N to π orbitals. That doesn't exist in H2 molecules. This is what you can see. This is what it is possible to see after lyophilizing 200 milliliters of naphionized water that is pure after every measurement, and this is the solid ponderal residue that is remaining. It is really impressive. But now we are sure that this is not something, that is not impurities at all. So we have this solid that is, in particular, it is stable at ambient temperature and pressure. Not only, but it is very stable. Okay, this is in the case of Naphion, this is the procedure. That is, it is an iterative procedure in which it is like washing a Naphion membrane in water. And this is, but many times. It is very interesting to see at different scale the solid residue appearance. I was joking a little, and I was calling this material that now we find in extremely diluted solution, that is from homeopathic solution, in iteratively naphionated water, in iteratively filtered water, and also other methods that we didn't publish yet. We obtain the same material with the same behavior. And in any case, water is pure. So I was joking, I was calling this matter that from now on, it is our duty to characterize. Because until now, we were fighting to be sure that it is pure water, okay? Now we understood that it is, and from now on, we are beginning to characterize. And so I was joking, I was calling xeros hydryle. From ancient Greek, xeros, dry, hydro, water, ile, matter, to give a name to this. As you can see, at visual scale, 1 centimeter, it has that appearance that, like in the last photo. If you see with the same image of the same matter, you can see that it is very similar. In fact, there is like a self-similarity. It is a scale that is two order of magnitude different. And if we are going with the atomic force microscope to see at 1 micron, we see like a similar web. But using atomic force microscope at trying to understand what is the way in which this matter is organizing, it was difficult because if you put 1 drop on the sample holder of the atomic force microscope, you obtain a lot of this matter. So you have to be careful to put only a little quantity of water. Otherwise, you see only a lot quantity of balls altogether. But putting a little quantity of water, it is possible to see this like the first 2 layers in a certain sense, no? And it is very interesting because you see that there are nanometer spheres that are connecting among them in wires, something like this. This is a same on the right. It is a same image of this matter, and on the left it is a 3D image of a protein, only to give an image. In any case, we normally, there is no wonder if the gold nanoparticles behave differently, even show fluorescent, even are fluorescent, very different from bulk gold, no? No wonder if this happens now. It is very well known. No wonder if gas ethylene is under a well-known procedure is becoming a polymeric solid. So something similar it is happening with water. These are the UV fluorescence spectra that are showing that at different concentration, the intensity is diminishing. So it is like a solute. It is behaving like a solute. Okay, this is the same idea. It is interesting that it has a distinctive absorption peak in the range 250-320 nanometer, with a maximum at 280 nanometer. Obviously, this peak is totally absent in bulk water. And the spectra consist of a broad band spanning from 290 to 550 nanometer. This is the characteristic. It is interesting that these absorbance, or UV absorbance, and fluorescence spectra also, resemble those of already measured by Pollack group of interfacial water adjacent to Nafion membranes. In this case, the UV absorbance of iteratively nafionated water resembles that of water near membranes, Nafion membranes, at a distance of about 450 micron. It is the same that you measured at this distance. In particular, it has in common the strong absorbance when the wavelength decreases from 240 to 200 nanometers. So it seems like an excimer type UV fluorescence. It is very similar also to other kind of water ethanol mixtures and other various aqueous solution in which it is possible to see this kind of fluorescence behavior. But it is not clear the origin until now. We too don't know, in effect, the real origin of this. Also, magnetized water is showing this behavior. But it is interesting. Okay, let's speak first that we were performing this analysis, as I told before. We showed that there are not contaminants, finally. So it is possible to be sure that there are no contaminants that are at the origin of this behavior. In particular, MALDI-TOF mass spectroscopy, gas chromatography mass spectroscopy, and there are only minuscule amounts of organic or biological contaminants that cannot account for this behavior, and also for the aggregates of this large quantity of aggregates. In particular, ion chromatography analysis show that the sole inorganic molecules released by the Nafion membranes are fluorine and sulfate ions. But these ions are present at concentration of about 10⁻⁶ mol per liters. These ions cannot account for what we see. But it is interesting what this Spanish theoretical group was showing 2 years ago in the journal Entropy. The title of the paper is, "Can the hexagonal ice-like model render the spectroscopic fingerprints of structured water? Feedback from quantum chemical computation." They considered the multi-layer honeycomb ice-like model. And they said, okay, let's consider a 10 hexagon layer. And when what happens? They were performing an ab initio calculation. This is the input, that is the output. That is, if you consider this ensemble of two anionic systems H19O10 minus that are situated in a parallel orientation and putting some symmetry constraint, they find that there is a geometry optimization of the resulting global system, that is H38O20 2 minus, and they were able to calculate that the output is that one. And this output shows exactly the spectroscopic fingerprints of structured water. Okay. So the result provided, as they say, full support to the scenario envisioned in the realm of biology by Albert Szent-Györgyi. In fact, Albert Szent-Györgyi said in his book, in the conclusion of his book entitled Bioenergetics, published in 1975, Lucretian biochemistry involves the assumption that no interaction can take place between molecules without their touching one another. Support is given in this book to the idea that manifold interaction can take place without such bodily contact, either through energy bands or through the electromagnetic field, which thus appears with water and its structures as the matrix of biological reactions. Quantum chemistry of this Spanish group shows indeed that water may form structures that absorb and transmit energy precisely in the same energy range as that arising from aromatic amino acids and DNA, RNA nucleobases. This is the theoretical what they obtained, the Spanish group. But it is interesting that the structure, the dimension, now we are at the beginning of the structural characterization of this matter, but it is already possible to notice that the dimension of these 1 nanometer, 2 nanometer spheres, it is very similar to what they find should be the origin of these spectroscopic fingerprints of structured water. I want to show in particular also, only because this is the classical doubt. Okay, but you are really sure that this is pure water? This is, for example, the mass spectrum of the principal components that you find. And it is very, you can notice that finally, you can notice that the principal peak is this one. Then there is the other peak is this one. It is so the principal is this one. It is very, very high. There is another that is OH, and there is a little also nitrogen, and the others are very little, and they are oxygen and CO2, a little of CO2. Nothing else, finally. A little of this, but really, as I told before. So the matter is not composed, but only by this. It is not. This is only spectroscopic measurements. So I want to conclude because there is not much time. UV absorbance and fluorescence spectra resemble those of other structured waters in liquid phase. But we isolated a new solid material at normal pressure and temperature constituted by supramolecular structures of H2O that we can call xerohydryl. And now I think that it is really possible to begin to investigate the natural hypothesis that is spontaneous dissipative systems forming impure liquid water, able to condense in certain conditions and becoming solid at ambient temperature and pressure, may be the matrix of life itself. So the first relation of yesterday, I think that may be related to this as the relation of Stuart Hameroff and Konstantin Korotkov. I think that probably may be related to this. I want to dedicate this work to the living memory of my friend and teacher Emilio De Giudice, that everybody of you knows very well. Thank you for your attention.
Thank you very much for excellent presentation. Very interesting. Very interesting. Thank you very much. Of course, now we have questions. So please, Vladimir.
Thank you very much, Roberto. It's, from my point of view, it's a real discovery next after easy water. So we're moving ahead. My question
it is the group of Vittorio Elia. Yeah. It is working on this for 20 years. Vittorio Elia is working from 20 years.
My question is like this. If you take this Xero, I don't forgot the name, and add water to it, what happens? Could you, if you wait for a long time, could you see some kind of multiplication of increase of this substance, or it is dissolved and loses its properties?
Okay, this is a very interesting question, because in effect what it is happening, we noticed it, but we didn't publish it, that if you are waiting, you are putting in a little beaker or something, this kind of water, in effect these structures are organizing until you see in the liquid water, they are becoming like a centimeter. It is like what you was speaking last year, I think. But like you remember, I don't remember the exact expression that Lamarck was using, but the molding, the matter, I don't know. You remember the Lamarckian molding matter? It is very impressive because they are becoming very large, in effect.
So Diraguin, the fear of Diraguin's polar water, which will convert all water on Earth into gel, comes true?
It was happening one time that trying to measure the viscosity in one of these measurements of viscosity of this kind of water. The day after, the expert of this measurement was finding that water that was passing through a capillary to measure viscosity. The day after, it was finding that in the sample it was jellified. All the Eppendorf sample was jellified, probably because the passage through the channel of the capillary channel was aligning, organizing quickly, probably much better this, and he was obtaining this. We didn't publish it. We didn't publish because it is, probably, I don't know. We will do. So.
I just wanted to point out, it was subtle in your presentation. You said that the absorption in the UV is a broad absorption with a peak at 280 nanometers. I just wanted to point out that when we measured it, we got 270 nanometers, so it's very close to that.
Yes,
yes,
very
close,
nice
confirmation.
Close, yes, it is close. Yes.
Yeah.
Thank you, Roberto. Could this be a super stable form of ice, and have you measured the melting point?
As I told, until a few months ago, the principal problem was to be sure that it is water. So now we have to begin all the possible characterization, and in this we ask for every possible collaboration from you, because it's obvious that we cannot do everything in Italy, or it is impossible. There is an impressive work to characterize well the liquid or gel phase and the solid phase, that obviously are different. So it will be very important to collaborate in this direction.
But we know that from Rome time, Italy was a place of new ideas, always.
Thank you.
Just a quick question, but Since you can get quite a lot of this material, what happens if you put
Please,
it...
can you...
Oh, sorry, is that better? If you can get quite a lot of this material, which seems to be the case, if you put it into a vacuum, would it evaporate? Does it evaporate and leave nothing behind?
No. Just the solid is obtained exactly by vacuum, how do I say, freeze drying. So you are putting the water in freeze, you are freeze drying, so you are doing vacuum, and what is remaining is that solid, or also drying at ambient temperature. So that solid, we were performing also thermogravimetry, and it is published. And performing thermogravimetry, you can notice that there are different phases in how do we say, in the when you are increasing temperature, this matter is evolving. How do you say, evoluting? How do you say? The exact it is going out. Okay.
Evaporating.
And to be there is a fraction of this matter that needs to reach 500, 600, 700 degrees to disappear. Okay. So it is very stable. It is very stable. Not.
And when it disappears, you find water.
Sorry?
Water vapor. When it disappears, you find water vapor. That's what I'm asking you.
Sorry, I am not.
When it disappears, presumably, you find water vapor.
Yes. Now, okay. Now we have to perform a thermogravimetry with the IR spectroscopy in line to follow this. But as I told, until now we were more. Now we are beginning to characterize, to understand. But this is the. We were doing also one measurement like this, and the results were of this kind. But yes, this is the important thing is you need hundreds degrees to break. This is the.
Okay, last question, please.
Yes, thanks, Roberto. Great presentation. Given the absorption in the range around EZ, is it really reasonable to conclude that this is just a solid form of EZ since it was naphthionated, among other ways? I mean, is this really what we're talking about, H3O2?
Sorry, I was not understanding well.
Are we talking about H3O2 in a solid form?
EZ?
Yeah, is this really solid EZ?
Probably yes, because as I showed, no, it is possible. Yeah. The idea is that you are also very you are taking off a part of EZ, and it remains a little ball of EZ, something like this, as I showed. Yes. In effect, it is very interesting because the theoretical study of the Spanish group is exactly, we didn't know before our experimental measurements, the theoretical. It is exactly connecting our results with the EZ structure. Like if you take a piece of EZ and it is organizing it because it is energetically favored in that little nanometer sphere. It is something like this. We have to understand, obviously, better, but this is the possible idea.